Hi all of you. In these slides we will see a brief review about micronucleus test, or what is micronucleus test is used for. Micronucleus test is used to determine if a compound is genotoxic by evaluating the presence of micronuclei. You should define here what is micronuclei. This figure here depicts the micronuclei in binucleated cells, as mentioned by these two arrows here. By definition, micronuclei are small membrane-bounded compartments or small nuclei-like structures. They are like normal nuclei, but they differ in the content and they differ in the size. With the DNA content, of course, encapsulated by a nuclear envelope and spatially separated from the primary nucleus. Micronucleus may contain chromosome fragments produced from DNA bricks, like it is mentioned in this figure here, and we can here speak about clastogenic effects. When the micronuclei contain fragments or bricks of chromosomes, we can say here that the effect of a chemical is clastogenic. It can induce bricks. And in another case, if these micronuclei contain the whole of chromosome or lagging chromosomes produced by disruption of mitotic apparatus. Here we can speak about anugens chemicals or amogenic effects. Let's see now micronucleus tests used in mammalian cells. This picture summarizes the main steps of micronucleus tests in vitro. Of course, to be carried out, micronucleus test is carried out using cell culture, as depicted in part A from this figure. Cells here are allowed to divide for one cycle. After one cycle, these cells are exposed to a chemical, to the tested chemical that is expected to be genotoxic. After one another cycle also, the cells will be washed to remove the remaining chemical, and in the same time cytokeratin B will be added. You know, cytokeratin B is an organic compound that is a mycotoxin which is cell permeable and inhibitor of cytoplasmic division that we call cytokinesis by blocking the formation of contractile microfilaments. So the cells will be allowed to divide for one more cycle, and at the end the cells will be harvested and we will get binucleated cells. Here the presence of micronucleus is considered as biomarker of genotoxic effects of the tested chemical. In part B also we have the same protocol. Cells will be allowed to divide for one cycle, which differ from the part A, that after one cycle the cells will be exposed to the tested chemical, and in the same time cytokeratin B will be added. After that they will be allowed to divide for one cycle, and after harvest we will get, of course, one cell binucleated cells with micronucleus. The appearance of micronucleus is due to the effects or genotoxic effects of the tested chemical. Part C here just depicts the effects of a chemical without the presence of cytokeratin B. Here, after being divided in for one cycle, exposure of cells to the chemical, to the tested chemical, and after one cycle, of course, of culture, cells will be washed to remove the remaining chemical without adding the cytokeratin B. After one cycle, of course, cells will be harvested, and at the end, rather than finding binucleated cells, we will find just mononucleated cells with micronucleus. Here, because we haven't added cytokeratin B, which blocks cytokinesis. You know, cytokinesis is the final step or phase in mitosis that gives two daughter cells. And this is all about the micronucleus test. I think it's not complicated. Thank you for watching.